So the first one, we have negative 2 times negative 1/3 to the x. So, Finn, do we have growth or decay? Okay. All right, we have decay. Okay, because we have 1/3. Okay. Then, what would be our domain? Emily. Negative infinity to infinity. Good. What would be our range? Rob. Yep. Okay, so for this one, what is our horizontal asymptote? Who has that? Nick? 0. Okay, or our horizontal asymptote is 0. Okay, so if you do not see anything added or subtracted on the outside, it's automatically 0. Now, what is happening with this graph? Yeah. It is a reflection, okay? It is a reflection because of the negative, okay? So since it's a reflection, it's going to be down, okay, flipped over, and our horizontal asymptote is 0. So our range would be negative infinity to 0. Okay, it's negative infinity because it's flipped over, and our horizontal asymptote is 0. So when you graph these things, okay, you start with your parent function, which is 1/3 to the x. You have 9, 3, 1, 1/3, and 1/9. That is your original parent function. But since you have a reflection and stretch in the beginning, you're multiplying all your original y values by negative 2. So we have negative 18, negative 6, negative 2, negative 2/3, negative 2/9. The most important ones you want to graph are your whole numbers, okay, either positive or negative. You know that the other two are going to get very, very close to 0, just never cross it. So negative 18 is off the graph, but you could also use it as a direction of where it's going. Then you have negative 1, 6, 0, negative 2. You have these guys. So it's flipped over. Remember, the decay graphs look like that. So when it's reflected, this is what it's going to look like and still represent a decay function. Okay. What is our y-intercept? Stefan? 0, negative 2. Okay. Now for number 2, what type of function do we have? Growth or decay? Kennedy? Growth. Okay. What is our domain? Chris? Negative infinity to infinity. What is our range? Luce? 2 to infinity. Excellent. Okay. Horizontal asymptote. Eva? Y equals 2. Good. So if you notice, again, horizontal asymptote and the range have the same number because you have the plus 2. Okay. So again, table of values. And our parent function is 4 to the x. Okay. And then we're just adding 2 to everything. Okay. So we have 0, 3, 6. Okay. What is our y-intercept, Porter? 0, 3. Good. Okay, good. So that's graphing one of each. Exponential growth and exponential decay. Okay. Then we get into our functions, our models here. Okay, so anytime it asks for exponential growth or decay model, this is what it would be, something like that. Okay, your model does not have your t value, like any years, in that exponent. Okay, if it's just a model, you're creating your equation that can be used for any question being asked. Okay, so the original amount of the car, Tate. 5,000. Okay. Typically right in front, or you can always do t equals 0. That shows you your original amount. Does this equation represent exponential growth or decay? Anthony? Why? Four is less than 1. Okay. What is our growth or decay factor? Camilla? It wouldn't be a percent, okay? The growth or decay factor is just this number. It's down here, which we'll do. So just the decay factor is 0.624. Okay, I'll get to your question in 1 second. Then, if you want to find the percent increase or decrease, what they did already to get the 0.624 was they did 1 minus r already. We don't know what the rate is. So we know that is less than 1, so that is our decay factor. 1 minus r equals 0.624. We have to work backwards to find the rate. So the decay factor is what is it attached to your exponent, also known as your b value. Okay. 1 minus r equals 0.624. What is our rate as a decimal? You guys have calculators on your desk. Let's do it. Yep. No, you're subtracting. Come on, use your calculator. How do we solve for r? What do we do? Zach? 0.376. You subtract 1. Negative r equals negative 0.376. Divide by negative 1. So your rate as a decimal is 0.376. Then you multiply by 100. 37.6% is your percent decrease. And it should always be positive. Okay, your question. Okay, so anytime you need to determine the growth or decay factor, it's the number inside the parentheses. It's done for you. Okay, you have to work backwards to find the rate. And if it's less than 1, it's 1 minus r. If it's greater than 1, it's 1 plus r. Okay? Now number 4. State the original amount of the bacteria. Liam. Good. Is this growth or decay? Rory. Growth. Good. So 1.257 is greater than 1. Good. All right. Same situation. State the growth or decay factor. Emily. Good. 0.257. Now to state the percent increase or decrease, you would take 1 plus r equals 1.257. Okay? Then you subtract 1. Rate is 0.257, making your percent increase 25.7%. Okay? So if it's larger than 1, okay, you have a growth factor, and you have to find the rate for the next question. 1 plus r. Okay? Are there any questions on the homework that you came across? This number 4. For the graphing? Okay. Okay. So this one, you would start off your table of values with 2 to the x first. Okay? So 2 to the x is 1/4, 1/2, 1, 2, and 4. Okay? Your original parent function. Then you would multiply your original y's by -1. Okay? You would multiply your original y's by -1. So -1/4, -1/2, -1, -2, and -4 first. This is just 2 to the x as the parent function. The negative is on the outside. So 2 to the x is those guys there. Okay? So once you multiply by -1, you then will add 4 to these original ones. So you would have 3, you'd have 2, and then 0. So these will cut out, these will cut out. So you have 0, 3, 1, 2, 2, 0. Okay, and then you have the smaller values as well. Okay. Yep. Number 1 on the graphing page. Okay, this one's just moving to the right. 4. So you have to do your parent function first. Okay. Okay. Here's your parent function. And obviously if you had -2, it's 1/9. Okay. Since you're moving to the right 4, your y values are going to stay the same. This is moving to the right, so you add 4 to x. So you would have 3 and 1/3, 4, 1, 5, 3, 6, 9. Those are new points. Okay? So if it's in the exponent, it's affecting your x value. Yep. This is from way back in functions as well. Okay. The opposite of what you just have. So you have a be the x minus h plus k. Okay. Same values. A, if it's less than 1 or less than 0, it's a reflection, meaning negative. So if you're still having trouble with transformations, I suggest you write this down. A is greater than 1, you have a stretch between 0 and 1, you have a compression. Okay? That's your A value, the number in front, which occurs first before you move up or down. Then x minus h, you're moving to the right, h units, so you add to x. X plus h, you're moving to the left, h units, you subtract from x. Okay? Then up, so add to y, subtract. And this is also your horizontal asymptote. Okay? The plus k, you add to y, minus k, you subtract from y, and that is your horizontal asymptote. Okay? X minus h, remember it's the opposite of what you see. X minus h to the right, x plus h to the left. It's been the same since September. Yep. 5F, right? Or 1F on the 5 point. So how many years? How many years did it take the population to reach 3.3 million people? Round to the 10th. So your model, and I saw a lot of crossouts for this. Your model is your original population, okay, your starting population, and then it's increased. So 1 plus 0.025 to the t. So, okay. Then in F, in how many years did it take the population to reach 3.3? So we need to find that t value. Okay. So for F, equals. Why do we set it up this way for those of you that were here? What, Tyler? Y1 and Y2, because what are we looking for? Where they intersect. Excellent. So anytime you need to find the years, okay? Anytime you need to find the years for the exponent, you have to do Y1, Y2. So in your calculators, the hardest part is figuring out the window. That's it. Okay? So we go into Y equals, okay? For Y1, you're going to enter in the left-hand side, which was 8.3 million. Okay. Y2 is the right-hand side, which was okay. And we're using the X, which is below the mode key. Okay. So this has to be done Y1, Y2 first. Can I take out your headphones too? Below the mode. To get the exponent, you do the caret first, and then do mode. Underneath mode is the X. Alpha and then what? STO, I don't know what that is. Oh, the capital X here. That's an alpha X. You could use the same thing, but this is your variable. Okay? So from here, once your equations are entered, Y1, Y2, you go into your window. Those of you that were here, your X value represents what? In this particular case, what does the X value represent? What are we trying to find? Years, so time, right? Do we care about negative time? So 0. Y max can stay the same. Now your Y minimum. You could do this a bunch of ways. You could put it in as 0 if you want. Okay? But the minimum value I see in those two equations is 3.3 or 3,300,000 is larger than our initial amount, right? So our minimum, okay? Now our maximum, you could write in the 3.3 million, okay? However, we want to see a little buffer because that's going to be a horizontal line. Okay, that's going to be at the top of your screen. So, I'm going to do enough zeros, yeah, 3.5. Okay, the Y scale, okay, I'm going to put 1,000. That's the increments. You could leave it as 1 though, if you wanted to. Okay. Then hit graph. So I suggest for all of these problems, you write down your window, what you adjust to. Okay, so you see the two graphs. You need to see both graphs and the intersection in order to run this next part. If you do not, you have to adjust your window. You'll get an error message that says no sign change. Okay, so second trace, number 5, and enter 3 times. Okay, 4.5 years. Okay. Any other questions on the homework? Okay. One thing that I will say, as I'm going, we are learning 2 more formulas, okay, that strictly deal with money. Okay. These 2 deal with money, so no matter what, we are rounding to the hundredths place. Okay, always 2 places after the decimal. We have compound interest, and we have compound continuously. Okay, that keyword continuously will mean a totally different formula. Yes, it's in there, page 7. You have that wrong. You're right. Page 11. I was looking at the wrong packet then. Page 11. It's okay. Okay, page 11. I was looking at the. All right. So you have your compound interest and compound continuously. Okay. Compound interest is over a specific period of time. Okay. That could change. Compound continuously, it's continuously increasing. So you're going to use a different formula for that. All right. But if you notice, the A, P, R, and T are the same as what we've been dealing with. Okay. A is your ending amount. Hasn't changed. P is your principal or your initial investment. So whatever you deposit, for example. R is your percent as a decimal. What is new is N. Number times compounded per year. So for example, quarterly is how many times per year? 4, is right there. Monthly, 12, okay? Semi-annually is 2. So your N values can be those, okay? And if you notice with the formula, you have P times 1 plus, it's always plus. It's always plus for interest. Your rate over the number of times per year And that n value shows up again in your exponent. However, I've seen this time and time again. I see people 1 plus r and then over n. That is not the case. It is your rate only over your number of times per year. Okay? So the n value is showing here and in the exponent. Okay? T is talking about years. Then if you have something called compound continuously, you're using something called the PERT formula. Okay? We will be using E, which is strictly in our calculator. It is an irrational number. If you look at your calculator and press second ln, which is below the log key, second ln, it gives you e to the exponent. Okay? That's the tool we're going to use. Okay? I use that one. There is another e button as well. But second ln gives us e to whatever exponent we're looking at. And that's what we want. Okay? Second ln. So, keyword for this formula is continuously. That's going to tell the difference between the two. I want you on this packet, please. So, let's look at an example, multiple different ways. And I'm going to go through the calculator, how to enter it, because sometimes it can be a little confusing. You deposit $4,000 in an account that pays 2.92% interest. Find the balance after 3 years if the interest is compounded with a given frequency. So, A is our ending balance. We don't know that yet. What is our initial amount? Yeah, Zach. 4,000. What is our rate as a decimal? Yeah. Percent. How would I write that as a decimal? Yes, there it is. 0.0292. Thanks, Zach. Okay. 0.0292 would be your rate as a decimal. Now, for quarterly, that's your n value. Quarterly is how many times per year? 4. Okay. So how this looks like using our formula, it's your initial amount, which is 4,000, 1 plus 0.0292 over 4. 4 times 3. Okay, so if you notice, the fraction bar, the division bar, is only here, not over the whole thing. Okay, so in your calculators, I'll show you 2 ways, one with parentheses and one step at a time. Okay, so clear out of this. Okay, so a step-by-step way, yes, you're solving for your ending balance. Okay, all right, so step-by-step without parentheses, so we don't mess up any parentheses. 0.0292 divided by 4. Let's do this in your calculator. Okay, plus 1. Okay, then I'm going to raise it. So I'm taking care of my fraction first, then parentheses. Raise it to, what's 4 times 3? 12. Then I multiply by 4,000. That's going step by step. Okay, so your ending balance would be $4,364.82. Okay, if you were going to do parentheses, okay, this is important, so you might want to jot this down too after we do it. 4,000, open parentheses, 1 plus. You need parentheses around that fraction. 0.0292 divide by 4, close parentheses. That closed out that fraction. Then you have to close the parentheses again. And then raise it to the 12th. So this is what it looks like. Yep. Time. Yep. 4 times 3. So n times t. Okay. And you get the same amount. Okay. But if you forget this parenthesis, what it's going to do is do 1 plus 0.0292, divide that whole thing by 4. So you need that fraction in parentheses. Okay? Does that make sense, you guys? Okay. So, what was it? Okay. So, for weekly, what's going to change about our formula? Yeah, Tyler. Good. N will be 52. So we have A equals 4,000, 1 plus 292 over 52, and 52 times 3. Okay. Do this as well in the calculator. Okay. 0.0292, and I'll do it separate. Divide by 52 plus 1. I'm going to raise it. 52 times 3. Those of you with, I think, a different model might see the caret show up. If you do, you're going to need parentheses around 52 times 3, just so you know. Okay, then times 4,000. Okay, so we have $4,366.10. Okay. Okay, so now the last one, we have C, continuously. Are we using the same formula? No, we're going to use the PERT formula. ERT. Okay, so A equals 4,000 E 0.0292 times 3. Okay, so in your calculators, you have 4,000 second ln, gives you the E in the exponent as well, 0.0292 times 3. Okay. Yep.
That one.
Huh?
For
There's no N in this one. There's no N. It's PERT. Okay. So $4,366.21. It's not much different.
the
Other formula. Yep. Okay? So, specific amount of time per year is your compound interest. Okay? Continuously, you're using the PERT formula. All right? Let's try a few more. One and two. Okay, let's do number 2. Okay. How long will it take to double your money if you invest it at a rate of 6% compounded semi-annually? What if it's compounded daily, if it's not a leap year? Okay, so they're not giving us an amount here, right? They're not giving us an initial amount. What is the smallest amount I can invest? Dollar amount. Tyler? $1, right? So our p-value can be $1. To double it, what would be our ending amount? $2, right? Okay. Now, for the first one, well, first our rate for both is what? 6% as a decimal would be what? 0.06. Okay? We don't know what t is. These values will be used for both questions. Okay? So the first one, where it's semi-annually, what does n equal? Nick? 2. Okay. So we have 2 equals 1 plus 0.06 to the 2 over 2 to the 2t. So since we're finding t, what do we have to do? We have to graph it. Y1, Y2. And our graph, our window, isn't going to be that large. Okay? So we'll go into y equals. Let's clear everything out in here. Y1, 2, Y2. You don't need to include that first one, but I'm going to just for formula purposes. 1 plus parentheses 0.06 divided by 2. Close that parenthesis for that fraction. Close it again. And then raise it, so the caret's below the clear key, to x. If you hit graph, we're still in that large window. Okay, just making sure everyone has this. Okay. Now go to your window. 0, 10 is fine. The y minimum, we could put as 0. The y max, you could do 5. And the scale, SCL means scale, so the increments can be 1. Okay. Hit graph. Do we see an intersection yet? So from here, since we don't see the intersection, if you were to try to do second trace intersect, you'll get no sign change because we don't see it. What do we have to adjust? This? So go back to your window. X max, let's do 15 or 20, whatever you choose. Okay, so you have to see this intersection. Go to second trace, number 5, and hit enter 3 times. So it will take 11.7 years to double your money. Okay, 11.7 years. So second trace, number 5, enter 3 times. Okay? So for the second part of that question, compounded daily, what's going to change? M? What will it be? 365. So go ahead and try that second question. What if it's compounded daily? N equals 365. Don't forget to put it in the exponent as well. How much money would you need to deposit now if you wanted to have $40,000 in 10 years if the bank offers 3.5% interest compounded continuously? Okay, so what formula are we using? PERT formula, good. Are using the PERT formula. Okay, what do we know? Yep. Time is 10 years, good. What else do we know? Yep. The N is 40,000, good. Okay, what else? Nick? Good. 0.035. So we're looking for P, right? Because how much money would you need to deposit now? So we have 40,000 equals P, and we have our E, 0.035 times 10. All right. So how do we go about solving for P? What would we do? What do you think? How do we solve for P? No ideas? What's the first thing you think you should do? Yeah, Rory. Okay, and then what? Excellent. Okay, so what Rory said was absolutely correct. Okay, you could do this multiple ways. E to the 0.035 times 10. Okay, divide on both sides. Okay, so we could do what Rory said, and second quit. If we do second ln 0.035 times 10, get a value, okay? Then do 40,000 divided by, to copy and paste that answer, second, it's minus sign, negative sign, copies it over, okay? So your initial amount that you would have to deposit, and we round up for this, okay? So $28,187.53. Okay? So even it doesn't matter what's next to it. If it's hundredths place, 0.52, you round up to the next cent. It's more accurate. It's exact, actually. Yep. Huh? Yes, Euler's number, yep. Okay, so you could have also done this, $40,000 divided by second, oops, I'm going to do parentheses first. Parentheses, second ln, 0.035 times 10, close parentheses, and you would get the same result. Okay, so we have 2817. Okay, this is what you would have to deposit in order to reach $40,000 after 10 years. Okay. All right, you guys are going to try 2 on your own. Okay. You're going to try number 3. Okay. Number 3 and number 5. Okay. Number 3 and number 5. Okay. You deposit $1,500 in an account that pays 3% interest compounded monthly. Find the number of years it takes for your balance to exceed $2,500. So, $2,500 is your ending balance. $1,500 is your principal, what you deposit. Then it's 1 plus, since it says compounded monthly, you're using the compound interest. 0.03 divided by 12 raised to the 12t. So then you go in your calculator. Y1 is 2,500. Y2 is the other part of your equation. Make sure you have parentheses where you need parentheses. It's 1,500, parenthesis, 1 plus another parenthesis, 0.03 divided by 12, close parenthesis, close it again, to the 12x. Okay? Now your window. I did at first 1 to 10 or 0 to 10, 0 to 15. I couldn't see it, so then I adjusted it. The X min is 0 to 20. Okay? My Y minimum I left as 0. Okay? You could have put your Y minimum at 1,500 as well. Okay? Y max, I bumped it up a little bit to 3,000. Your scale, I put 100. You could leave it that at 1 if you wanted to. Then hit graph. Now you actually see the intersection. If you're seeing 2 straight lines, your x is not in your exponent, or you don't have parentheses around 12x. Okay? So from here, second trace, number 5, enter. 2 times. You should have got about 17 years. Okay, yep. Okay, let me see. Okay. Nick? Okay, 14,000. 6 more, right? Okay, good, excellent. What was your interest earned? Anybody can answer. What's our interest for Bank A? Yep. That's our rate. How much interest did we earn in 10 years? What's the difference between those two numbers? Yeah. That's your interest, okay? You only deposit 10,000 and it's gaining interest, which was $4,888.64. For Bank B, what is our total? Rob. Say that again. Might be a little too much, I think. So 15,000 is right. Go ahead, Nick.
I got 15,000,
So 15,000, $17, and what's the 33 cents? Okay. Rob, we'll check your equation. Okay. Yeah. You take your total and you subtract your principal. That's how much interest you gain. Okay? Okay, so for your interest for Bank B, $5,017.33. Okay? Which bank gained more interest? Yeah. Bank B. How much more? That's part of the question. Bank B gained more interest. Okay. And how much more interest? Yep. Okay. We get that total by how much more interest by subtracting these two totals. Okay. $128.69. Okay, I believe, right? So, when you're doing these and comparing, okay, make sure you have the right equation. Parentheses, if you use parentheses, make sure they're in the right spot. Okay, for this one, we really just could have done 10,000 parentheses 1.0415 to the 10th, and you would have got it. Okay, because this over 1 is just that number. 1 times 10 is just 10. Okay, so we went through a lot in terms of the formulas and finding different pieces. Okay, just 2 additional formulas. Your homework is on the board in the yellow packet. Okay, you have both 5.5, which was last lesson, and this current lesson. Okay, there will not be homework over break, but I see you guys again on Thursday. All right, good work.